Okay, so just to catch some people up, there's lots of geometric transformations, okay? So one of those transformations is like, for example, dilating, which is like scaling everything, okay? Another one of them is rotating. Yeah, another one is reflecting. Yeah. That kind of stuff is like classical geometry. Something more advanced, which is not a full transformation, is called inversion. Okay. So inversion is kind of like reflection, but instead of reflecting about a straight line, you're reflecting about the circle. Okay. And the definition of inversion is if you have a circle, okay, and you have a point, okay, called P. The point that it gets inverted to, P prime, has the property that the lengths OP times OP prime is equal to the radius of the circle squared. Okay? So if we pick a circle with radius 1, then they're literally reciprocals of each other. Okay? And maybe that's one justification for inversion. It's like you're inverting the number. Okay, but it has all these nice geometric properties, okay? So obviously if you have a point on this ray and you invert it, it stays on the ray, right? If it's inside the circle, it goes outside the circle. Okay. Um, okay, so something that's less obvious is that if you have a circle which passes through O, okay, it gets inverted to a straight line, okay, that does not pass through O. So this circle turns into this line, okay, and the reason the line goes through these points of intersection is because points on the circle are fixed by inversion, right? Because if it has a radius 1, for example, then 1 over this length is still 1, right? Okay, so it has to go through this point, and if it's a straight line, then it has to be that straight line. Okay. And obviously, if you have two shapes, like a circle and another circle, and you invert them both, then those two, so a circle stays as a circle under inversion if it doesn't go through O. And obviously, if it intersects twice, like this, the resulting shapes will still intersect twice. Okay. And if you have a circle that's tangent like this, okay, then the resulting shapes will still be tangent, okay? Because essentially it's one point of intersection. It has to stay as one point of intersection. Okay, how does this relate to us? So for this problem, when circles are tangent, okay, inversion works really well, okay? So let me show you what I mean. So let's pretend that this circle centered at this point. So let's call this point the origin, okay? And let's call this circle of radius 1, yeah? The circle of inversion, okay? So we invert everything about this circle. What?
Radius 1.
Yeah, I feel like you're mentioning some very trivial point. Okay, so we're inverting about the circle of radius 1, okay? So remember what I said, a circle that goes through the O inverts to a straight line, right? Okay. Alright, so and we also know that this line gets fixed by inversion, okay? Because remember we said lines through O stay as lines through O, okay? So what does that mean? Well, the thing is, the circle inverts to a line, right? And this line inverts to a line, okay? And they originally had intersected only once, right? But the problem is they intersected at a special point O, which doesn't have a definition for inversion. Yeah, the inversion is defined for every point except for O, because you can't divide by 0. Okay. So what that means is the line that the circle goes to does not intersect this line. Okay. And if two lines don't intersect, then they're parallel. Okay. So a parallel line looks like this. Okay. So this circle goes to this parallel line. Okay. Now these other two circles, so these other circles, they don't actually go through the O, right? So they're going to be turned into other circles. Okay. But because this circle is tangent to this line, right? And is tangent to this circle, then whatever circle it goes to is going to be tangent to these two lines. Okay. So it actually turns. There's only one circle there's only one kind of circle that's tangent to these two lines, right? It's a circle like this. You know? That makes sense. Okay. And now the small circle, okay, is tangent to all three things. Okay, so it's tangent to the top line, the bottom line, and the blue circle. Okay, so it's literally the only way I can do that is be a circle like here. Yeah. Okay, or it's on the left. Yeah. But we know it's not on the left because sort of inversion. You know what I mean? Like if you're inverting a point, like 1/5 is bigger than 1/8. You know, so like it reverses the order. Okay, so this is circle 3, circle 3. This is circle 2. Okay. 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 So the question I'm going to ask you, hopefully you can answer me. I have a little bit of time for this. What are the values of these points here? You know what I'm talking about? So like where do these circles touch the bottom line? Yeah? Does that make sense? What my question is? Like these two circles here, this touches at X, right? This touches at 3/8. Where does this touch and where does that touch?
Let's see, two touches. It's just what's R squared 1, right?
Yeah.
So we know that it's 8 3. 8 on 3.
Close.
But we know that R is, so we have 1 is equal to, and we're defining it as the origin, so 0.
Yeah, so remember when we had the definition of inversion, right? We said that P goes to P prime and this distance times this distance equals 1, right?
Yeah.
So at this point we're sending this circle to there, right?
It was 1 on 24, right?
Yeah. So in this diagram, this distance here is 1 on 24. Yeah. So can you tell me what this distance has to be then?
That's it.
What's someone else saying? So the question is, what is this distance?
24.
Yeah, it's 24. It times the 1, right? So that means this distance here is 24 away from O, yeah? Which is actually 24 plus a third, right? Yes? Okay, then the next question is, what is this point here? Where is this point?
Diameter of circle 2. It's like plus that point plus the diameter of any of this stuff. It's just what's the radical axis of the circle with radius 1 and circle with radius 9? I don't need to
Maybe Charlotte can tell me this one. So where is this point now? Hmm? Anyone know? I'll give you 5 more minutes. So remember, we have this point comes from this point, and it goes to 24. Yeah. So then, what is this point?
Is it 1 on x minus a third?
Oh yes. Okay. So yeah. So it's the same situation, right? Except this point is now going to this point. Yeah.
Yeah.
And this distance is x minus a third, right? So this distance is 1 on 24. It flips to 24. Yeah. This distance is x minus a third. It flips to 1 over x minus a third. Yeah. Okay. Okay. My next question to you is, what is this distance? What is the distance between the two parallel lines?
It's the distance.
Hmm? I mean, it's not drawn to scale. It's a bit misleading, but what's that? So before, so just then we had this x minus a third, right? And it becomes 1 on x minus a third. Yeah. Now I'm asking you what this distance is. What point? Oh, okay. I think you've answered the next question now. I'm looking for a current question.
Nine.
If you agree.
Oh.
Hmm?
So the other one's just.
Yeah, so this circle is what turns into this line, right? So it's this point on the circle that turns into this point on the line, right? So it's not really drawn to scale, but the point is like now this thing here is 1 on 9, right? So what does that make this other length then? You flip it, right? So it's 9, you know?
Oh.
Okay, so this distance here is 9, yeah? Okay, so my next question is, what is this distance here? And Liam cannot answer this. And let's just say Alan cannot answer this. But you can say that you know the answer or something.
I know the answer.
Yeah. I think Charlotte already knows the answer to this. Maybe Charlotte could share the answer that she knows. I'm not saying it out of speculation. I feel like you actually said the answer already, so
It's 9, but it's also
yeah. So can you see that this distance here, right? It's the same as this distance here, right? Is that obvious to you? Because that's like the diameter, right? Radius. Like that's like a square, yeah? That's like a square, yeah? So it goes 9 up, so this must go 9 across, yeah? This distance is 9, yeah? Okay, but we already know another way to get that distance, right? It's this thing minus this thing, yeah? So it's 1 over x minus a third minus 24 minus a third equals.
Where are you getting the minus a third from, sir?
This one, the third minus the 5.
Right. Why is it? Oh, you're getting the actual position.
Actually, I need a plus a third here, don't I? Yeah.
That's suspicious. 1 x minus.
I don't have a third. This should be a plus a third actually, because it's 1 on x minus a third from O, but O is a third, so it should be plus a third. Okay, can you see from this you can solve for x? So I want maybe Jenny to tell me a solution for x here. Oh, Ryan, where's Ryan? Ryan. You can use pen and paper if you want. It doesn't have to be like completely head solved. Ryan? You want pen and paper? Oh. So 1 over x minus a third minus 24 equals 9. What is x? What the? Okay, maybe I'll ease your memory a little bit by putting the 24 with the 30, the 33 here. What is x? I guess I do like people trying to go for a challenge. I kind of try and do this in their heads. In this class, I'm more inclined to give people the benefit of the doubt. In some other situations, I feel like people just, when someone's doing this, you can't tell the difference between solving it in their heads and just kind of staring blankly doing nothing. Okay. So, what's Ryan doing? Hmm.
Yeah.
Okay, so look at this. So if you reciprocate it, right? So 1 over 33 is equal to x minus a third, right? So x equals 1 on 33 plus a third. You know? What is 1 on 33 plus a third? Yeah, it is 1 over 3 outside of 1 on 11 plus 1, right? Which is 12 over 3 times 11, yeah? So this is 12 over 11. 1 on 3, this is 4 over 11, yeah?
Yes.
Okay. Yeah, it's a pretty neat solution, right? Yeah. I think that's the first AIMO question I've seen use with an inversion. But I think we should revisit question 7 and see if that works as well.
This feels like the cleanest solution by far, and the most elementary.
Yeah, and so also, if you know what x is, it's easy to find the radius as well, okay? So let me just do that quickly. So if you know what x is, and you want to find the radius, let's call the radius r.
Just
Yeah.
do what we did for
Yeah. We actually had an equation already. So we could do pretty much any of the triangles, yeah? For example, we could do this triangle, yeah? So this is 1 on 18 minus r. This is
trivializes the investigation.
1 on 18 plus r. And this is x minus a third, right? So x minus a third squared plus 1 on 18 minus r squared equals 1 on 18 plus r squared. Okay. And the thing is, we already know what x is. X is 4 on 11, right? So we only solving for r, really. So then you put it on the other side. It's a difference of 2 squareds. You get 2r outside of 1 on 9 is equal to 4 on 11 minus a third squared. Okay. And what's 4 on 11 minus a third?
Sir.
It's 12 minus 11 on 33. Yeah, so it's 1 on 33 squared. Times equals 2r on 9. Yeah. So 9 goes on the other side. 9 on 33 squared. 2 goes on the bottom equals r. Okay. And so r equals characteristic dependability. Okay, r equals the 9 cancels the 3. So you get 1 on 2 times 11 squared. Okay. And that's it.
This also really trivial extensive investigation.
Oh, yes. Oh, good. You're gonna show us. Wait.
When did you solve the thing?
Just then. You get the same numbers? Oh, very nice.
Is it worth it to do the investigation during the test?
No, you can't do the investigation and test. It's pointless.
Oh,
The investigation is like a trap for the test.
they scam you.
It's interesting to do it after the test, sure. But like investigation, like it's not worth anything unless you get full marks. So like if you haven't got full marks,
I feel like
then
there is an exception because the investigation, once you reach that inversion solution, is so trivially obvious. It's like,
so one thing about the investigation is if your solution to question 10 also works for the investigation, then it's usually like kind of it's almost like it's intended, but
but that would make the inversion something like that. Inversion like trivial.
Alright, you guys have any questions? I think Ethan has a